Hello viewers, I trust you are good. Alright, the task before us is the trigonometric identities. And if you can remember, in the last video I produced under trigonometry, when I spoke about the basic trigonometric ratios and their reciprocals. I made mention towards the end of the video that I was going to kick off my next video on the trigonometric identities. So here we have it. So basically, we have 9 trigonometric identities. There are 9 trigonometric identities, but these 9 came out of just 3 trigonometric identities. The 9 trigonometric identities came out of 3, and these 3 in turn came out of just 1 trigonometric identity. In other words, 1 produces 3, and 3 in turn produce 9. So we're having 9 in total. So I'll take you through those 9 trigonometric identities very quickly. And you'll see how they are coming up very easily. Stay with me. So here we have it. The very first identity and the most important that will birth the remaining 8. I'd like to call it the number 1 identity. Okay, so from this, I'll be bringing up the number 1a. I call it the number 1a. So I call it 1a. And how do we get 1a? We want sin² theta to be the subject of this identity. That means cos² theta has to leave this place to come and meet 1. So we'll be having sin² theta being equal to, by the time plus cos² theta crosses the equal sign, it becomes minus. So we're going to be having 1 minus cos² theta. So this is the one I called the number 1a identity. So you see how it comes from the very first identity very easily. Then I will be having the number 1b. Excuse me. Number 1b, still to come from the number 1 identity. Now this time around, the cos² theta will be made the subject of this identity. That means sin² theta has to leave here to come and meet 1. So we'll be left with cos² theta equals 1 minus sin² theta. And of course, this is the number 1b identity. So we're already having 3 identities, and these remaining 2 are coming from the number 1 identity. Let me circle it. Okay, we're moving on to the second side of the board, and that is for us to get the identity number 2. Now, how do we get identity number 2? Still from identity number 1. We have sin² theta plus cos² theta equals to 1. So what we need to do first of all is to divide through by sin² theta. So we'll be having divide through by sin² theta. So that is the statement, and the illustration is for us to have sin² theta divided by sin² theta plus cos² theta also divided by sin² theta, and that's going to be equal to, after the equal sign, we're having 1 also to be divided by sin² theta. Make a reference to the previous video that I did. We'll be seeing how some of this will be coming up. So sin² theta divided by sin² theta, of course these are 1 and same, so that's going to be what? 1, because sin² theta divided by sin² theta will give us 1. Then plus, okay, so from our previous video we were able to see that sin theta over cos theta is equal to tan theta. That is a fact from my previous video. Now, if we switch this up and down, up, the down going up to become cos theta over the up coming down sin theta. Now it means that we are going to have 1 over tan theta because it is assumed that this tan theta is over 1. And when we have 1 over tan theta, we are having what we call cot theta. You can check that out from my previous video. Okay, so now we're having cos² theta over sin² theta. When we have cos theta over sin theta, it is cot theta. Now it is cos² theta over sin² theta. Of course, what is that going to be? That's going to be cot² theta. And that's going to be equal to the reciprocal of sin theta is cosec theta. So definitely the reciprocal of sin² theta is going to be cosec² theta, and this is going to be our identity number 2. Identity number 2. That's the identity number 2. Okay, now from identity number 2, we need to get identity number 2a, and we need to get identity number 2b. Okay, so we are going to have identity number 2a. First of all, to make 1 the subject of this formula, or this identity rather, we are going to be having 1 equals cosec² theta minus cot² theta, and this is identity number 2a. Just like we have 1a and we have 1b, so we'll be having identity number 2b. And what is identity number 2b going to be? It is, instead of making 1 the subject this time around, it is cot² theta that will be made the subject of the identity. So we'll be having cot² theta equals, so 1 has to leave here to go and make cosec² theta. So we'll be having cosec² theta minus 1. And of course, this is identity number 2b. So how many identities are we having in total? We're already having 6 identities. 1, 2, 3, 4, 5, and 6. So we'll proceed to the last 3, which will bring all our identities to 9. Okay? To the next line. Now to get identity number 3, now this time around, instead of dividing identity number 1 through by sin² theta, we'll be dividing through by cos² theta. So we have divide 1 through by cos² theta. And in that case, what are we going to be having? We'll be having sin² theta divided by cos² theta plus the next one, cos² theta divided by cos² theta, because the instruction says divide through by cos² theta. So you divide the first one by cos² theta, divide the second one by cos² theta, and of course, lastly, the one after the equal sign also will be divided by cos² theta. So the next thing now is to see, what does this represent? What does this represent? And what does this represent? So we give them their technical names. Sin² theta divided by cos² theta, of course, is going to give us tan² theta, because we knew before now that sin theta over cos theta is tan theta, and that's going to be plus cos² theta divided by cos² theta. That's going to be equal to 1, because they are one and same, so they cancel out, and this is going to be equal to 1 over cos theta is sec theta, In that case, 1 over cos² theta will be sec² theta. And this, of course, we're going to call identity number 3. And I want to believe, just like I'm reading your mind, that you're already guessing what identity number 3a is going to be and what identity number 3b is going to be. So let's run through that very quickly. So identity number 3a is for you to make either tan² theta subject of the identity first of all, or you make 1 subject of the identity. So if you make 1 subject of the identity here, you'll be having 1 on the left hand side becoming sec² theta minus tan² theta crosses to go and make that to become minus tan² theta. And of course, this is identity number 3a. Now, identity number 3b, instead of making 1 the subject this time around, we'll be making tan² theta the subject. So we'll be having tan² theta equal to sec² theta minus 1. And of course, this gives us the identity number 3b. So how many identities are we having in total? This is 1, 2, 3, 4, 5, 6, 7, 8, 9. And like I said earlier on, these 9 identities came up from just 1, 2, 3 identities. And these 3 identities also in turn come up from this very first identity. So this very first identity is the mother of them all that birth the remaining 8. So these are the basic trigonometric identities. And these identities are so important anytime you want to prove trigonometric identities from left hand side to being equal to the one on the right hand side, or you want to prove from the right hand side to be equal to what the one on the left hand side. But I say to you, very importantly, that you don't need to commit all of this to memory. You don't need to cram, you don't need to do whatever it is. The very weapon that you need, the very one weapon that you need is just this number 1 identity. Once you have this number 1 identity, you can bring up 1a, you can bring up 1b, you can bring up number 2, you can bring up 2a, you can bring up 2b, you can bring up number 3, you can bring up 3a, you can bring up 3b. But one key skill you must have is you being flexible. You must be very flexible because, of course, when you want to work with trigonometry in mathematics, flexibility is needed. You don't make yourself too rigid, because when you become too rigid or you make yourself too rigid, you will not be able to move in in the path that these identities will want to take you through. But when you are flexible, you can take any shape, you can take any form, and then you see your identities coming right before your eyes. So I present to you the trigonometric identities. In my next video, I'll be working on the addition formulae as well as the double angles, and you'll see some uses of the trigonometric identities also in that particular concept. Until then, I leave you with this, and I say, stay safe and stay good. Thank you.